Hey guys, so welcome back to the Python and its basics tutorial where I am going to show you today about fuzzy sets yet again, and this time it's going to be the union and intersection between two given fuzzy sets. Now, as I said earlier in the previous video, what fuzzy sets are and where it's used, it is used in soft computing. But in this case, I'm just going to show you the union and intersection of two given mathematical fuzzy sets that is actually used in soft computing uh, in Python. So let's get started. So in your school days, you must have learned what sets are, and in your maths class particularly, you must have come across the term union and intersection of fuzzy sets. So how do we calculate union and intersection sets? In maths, what we have learned is we take the maximum of the elements, provided the elements are the same, in each set. So the maximum of the membership values is what we consider to be taken as a first element or each element in that set as a union set. Similarly, in intersection, we consider the minimum of the membership values in each fuzzy set. Now, moving on to the code, I can say that there are two segments. One is a class union intersection, which contains three methods and one default constructor. In my previous video, I have already mentioned that fuzzy dictionary is a default constructor that has been initialized here, and self is the parameter that we are passing so that I'm able to use fuzzy dictionary in the entire class. Now, in the main method, the first line of instruction that we see here is that the user is being asked to enter the number of elements. Now, those elements are basically used for each set, set A and set B. The number of elements is basically the size of the set. So, in line 79, right here, fs1 is an object that has been initialized by with union intersection class. Similarly, fs2 is an object, an instance of that class union intersection. Now, when the user enters the set element and membership value, as I had mentioned earlier in the previous video, that we are using the fs1 object and likewise with fs2 to call the method create fuzzy dictionary, which is present inside the class union intersection. Now in line 30, which is defining the method create fuzzy dictionary, I had mentioned before in the previous video that we are checking to enter the element, and if the element already exists, then we just ask again the user that enter the element, and if it doesn't exist, if it is a new element, then we just break and we move ahead in life. Same with the membership value. If we fulfill this condition where it is between 0 to 1, then we follow either this statement, that is line 41, where we enter the membership value into the fuzzy dictionary for that particular element, or we follow this statement, which is basically the same. In here, we just follow the update method and we update the element with a particular membership value inside that fuzzy dictionary. Now, you might ask, or why have we used indexing here? So, I will particularly tell you that we have given third bracket, which shows that this might look like a list, but this is not a list. Fuzzy dictionary here is of type dictionary. So, when we are entering the membership value inside the dictionary, we are basically asking the fuzzy dictionary that inside that element, or basically in that dictionary, I want to enter this particular membership value inside a particular element of that particular index. Now, this index, I would say, refers to the dictionary, not a list. So, when we refer to indexing in a dictionary, we can refer to third bracket. But when we refer to a list, we can just say that it is plain simple indexing. So I'll close this, create fuzzy dictionary, and move ahead to after we have entered the entire set, that is fuzzy set A and B. Now we want to print the sets. This is how we do it. We use the object and we print the fuzzy dictionary. But why have we used fs1 dot fuzzy dictionary? Are we getting the fuzzy dictionary inside the main? Aren't we getting the fuzzy dictionary in the main method? The fuzzy dictionary is inside the class. It has been initialized inside the class. So inside the class, we can use fuzzy dictionary in any method we choose, in create fuzzy dictionary, in union method, and in intersection method. And in these cases, we always use the word self. Why? Because fuzzy dictionary belongs to that particular class. So in the main method, when we are referring to the fuzzy dictionary that is inside this class, we always use the object, so that we know that this particular fuzzy dictionary belongs to this object, and the fuzzy dictionary, the same fuzzy dictionary, belongs to a different object of the same class. That means that we are referring to fuzzy dictionary of set A belonging to fs1 object and fuzzy dictionary of set B belonging to fs2 object. So after we have printed that, we are basically asking that the program should be executing line 91. Now line 91 says that I am using fs1 to call the method union, and we are passing a parameter fs2, which is the second object. Now fs1 basically contains the first object. The first object is a set A, and set A contains the elements and the membership values in that particular set. And fs2 is set B. That means that set B has the elements and membership values of set B. So we are basically calling the method union, and this method is basically responsible for calculating the union of the set A and B. And the result is what we store in union result. Likewise, we do with intersection. So what is inside union and intersection methods? Let's check it out. In union method in line 47, we see two parameters here, self and other set. Now self, we know that if we are passing nothing inside, that means that this particular self, we have access to that object. Means this object, uh, if we don't pass anything, that means that we have access to this particular class method. So we use self for that. And other set is basically we are passing fs2 for. Now fs2 is the basically for the second object that we have created, and we pass it as a parameter for the union method. So fs2 basically is the other set. Now what is fs2? Fs2 is the object here, and when we are passing it here, we are basically seeing that object which is of type union intersection. Why? Because fs2 is what was created as of type union intersection, as we can see in line 84. Now this union method is returning a dictionary to us. As we can see here, the result, it is a dictionary which is basically containing the union set of A and B. Now in line 48, we are creating, or rather declaring and initializing the dictionary, and it is inside the variable, inside the result, reference result of type dictionary. Moving forward to line 51, where we see that we have all keys. It says that it is a combination, it is to combine all unique elements. Now I'll just help you look at this entire statement. I'll just break it up into parts, where self dot fuzzy dictionary dot keys method. So self dot fuzzy dictionary dot keys method is nothing but the keys of the first element. How do I know is the first element? Because I've used the word self here, and self is the first parameter. So we are referring to self, that means we are referring to the first object. And when we are referring to other set here, which is the second part of the statement, which is set B. So set A, I want to access all the keys. Keys means the elements compared to the membership value. We just want the elements. Now, likewise, with this, we just want to see the elements of the fuzzy dictionary of set B. Now, this entire thing is basically the set A, and this thing is set B. Now, when we compare set A dot union in brackets set B, that means we are finding the union of set A and set B. So union is a method that is provided by Python itself, and it returns a new set with elements from the set and all others. That means we can have more sets, more than two sets. We could have also written this as using the pipe operator, which is this, and just write set. This is another way of writing it. So after we have calculated the union of set A and set B, we store that. We get a collection of all the keys of set A and set B, and we store that in all keys variable. Now I have access to the entire set of keys that is available in both set A and set B. Now what we are doing here, as I execute the program, I will be showing you that we have taken common elements in both the sets A, B, C, and D, considering the number of elements as 4. Now in those 4 keys, those 4 elements, we have access to each element and we check each element. Now in line 54, we are basically having value 1, and in line 55 we have value 2. What are we storing in these values? Now here we have self.fuzzydictionary.get key comma 0. That means that Python gives us a get method which we are using here for the dictionary, and we are accessing the key. For that particular key, we want the value and we store it in value 1. So we are getting the value using that particular key, accessing this particular key right here. And if we get nothing, that means we set it to 0. That means this value 1 contains 0 if we don't get the value for that particular key. Similarly, we do with the other set, that is set B. If we don't get the key, then we set it as 0. In line 57, we have same as what we had right here. It is syntactically the nothing different from it. Here we are just having the result, which is calculating the max of value 1 and value 2. That means when value 1 and value 2 is compared, we will be calculating the maximum value. Now value 1 and value 2 is what? Is basically the membership values for each element. Now we have all the keys right here. Now say all the keys contain A, B, C, and D. Now say key right here is A. So when we access A, we get the membership value for A in value 1 and membership value of set B, A, and we put that in value 2. So when we compare those two values, whichever the higher value is, we put that into the result set. Now result is of type dictionary. So as I had mentioned right here, I've initialized it as an empty dictionary. So when we get the higher value, we put that into the dictionary using that particular key. Now it will be set to key A, that is the first element. Likewise, this loop will go on till the number of all keys, which is 4, which is A, B, and C, and D. So when it returns the result, what we now have is the dictionary which contains the higher values compared with the membership values compared to each element in both the sets. Now, likewise, in intersection, what we have here is we have mentioned as before, as this other set, which is set B, is of type union intersection. I have declared and initialized the result dictionary right here, and it is pretty much doing the same thing, except when we get the values from that particular key, we are calculating the minimum value. So this minimum and right here this maximum is the only difference that you will find while calculating the union set and the intersection set. Rest, the entire code and the entire logic is basically all the same. In one we calculate the max value, and the other we calculate the minimum value. So that's it. So let me just execute this program and show you what I get. So I'll just minimize this a little to show a little bit of the program, and I'll run it using the Python command, Python 3 command rather. The name of the file being 3 underscore union underscore intersection. Press tab, and then a whole file name comes. Now I am asked to enter the number of elements, which I enter as 4. So for set A, the element I will be entering is A, the first element, and its corresponding membership value as 0.7, B as 0.2, C as 0.1, and D as say 1. Now for set B, all the elements I'll keep the same, 0.8, and the membership values should be different to be able to differ from each other, the union and the intersection. And I'll give this as 1. New element C 0, and D I'll give it as 0.8, all of which are between 0 to 1, all membership values. So on this calculation we see two things. First is that there is an ordered dictionary of set A and set B, A, B, C, and D. Um, we calculate the union, which is an unordered dictionary, likewise with intersection. And I'll tell you why. Uh, that is because we are using a set in between inside that union method and intersection method. But to actually calculate and check if the min and max method in each union and intersection methods respectively are being used or not, in and element A in set A and element A in set B, if we compare, the union of this set is 0.8, which is a higher value. So we consider this, and for B it's 1, which is greater than 0.2, so B will be 1. C is 0.1, which is greater than 0, so it's 0.1, and D is uh, 1, which is greater than 0.8, so we consider 1 as a union element in the particular set. And for intersection we choose the minimum value, so I guess it is the opposite of what we have in the union. So in element A we'll get 0.7, which is lesser than 0.8, and likewise we go on till element D. So the reason why I wanted to tell you that why this is an unordered dictionary is because inside this method union and intersection we are using a set to wrap the dictionary that we have, that takes the keys and sets them all into all keys. So while we are doing that, the dictionary which is currently ordered now becomes unordered. So while doing then calculation and setting out the max value of each and setting them into the result dictionary, we are now having an unordered dictionary. Hence, we see that this dictionary is unordered. Likewise with intersection, we are using the set method here. The reason being that we want to convert everything in a set all unique, so all unique elements, so we want these keys into this and into all keys and calculate the minimum value for each key, comparing each value for each element. All right, so that's pretty much it for this one. If you have any questions, whether it's related to Python or fuzzy sets or even the operations we did, just list them on the comments below. And in the next few videos, I'll go deeper into things like algebraic sum or probabilistic sum and also bounded sum. We will not forget that. So we'll build on this step by step. If you found this useful, stick around, there's more coming. See you on the next one.